Hi everyone, this is Mr. On. So in this video, I will go through this worksheet on states of matter. So this first question is a very straightforward question. It's asking which change of state involve particles losing energy. So the type of energy that we are talking about being lost would refer to kinetic energy. So the lesser your kinetic energy means that you lose your energy and therefore you move slower. So this is all to do with kinetic particle theory. So as you move slower and slower, you will eventually result in a change of state, either going from gas to liquid or liquid to solid eventually. Okay, so and they move closer together. There's another hint on how they packing. All right, so one is to do with movement or motion of the particles, the other one is to do with packing, and you know it's to do with motion because it's to do with kinetic energy and you're losing kinetic energy. So you need to circle it, so based on the question. So with this kind of any question really, when you read the questions, you're obviously allowed to underline or do not use highlighter, but underline or circle or whatever that you have been instructed to do. Okay, so as I mentioned, you will lose kinetic energy and you move closer together. As you do gas to liquid, that is your condensation, and you will also get the same deal when you do liquid to solid, that is your freezing, but not solid to liquid, because solid to liquid, your particles are actually getting further and further apart, and in fact they increase in your kinetic energy, so they actually move faster and they move further apart. Same deal with liquid to gas as well. All right, so let's change the ink here. In this question 2, the table shows the melting and the boiling points. So they are both melting and the boiling points. So melting point means is the temperature at which you go from solid to liquid, and boiling point obviously is the temperature at which you go from liquid to gas. All right, so in which are the particles in an ordered arrangement? All right, so the question is not very specific, it just say ordered arrangement, and we know very specifically, well, we know for one thing that it is not going to be a gas, because when you have gases they are not ordered at all. At least in liquid it's still ordered, but you know there's a little bit of space in between the particles, such that they can move a bit more than if they are in the solid state. All right, and the other thing that you might not have known is this thing called room temperature. It's already written there, so I don't want to have to repeat it. Room temperature is 25 degrees Celsius. So what can we say? Yeah? So we are looking essentially at what happened at 25 degrees Celsius. So what happened at 25 degrees Celsius? Let me show you what happened for the first one. So if this is temperature, so the negative scale is lower, so there's minus 115 degrees Celsius, and 79 degrees Celsius is the boiling point. This is the melting point. So what it means is anything lower than the melting point means you haven't melted, so you are still a solid. At the melting point, your temperature will remain constant because the solid is becoming liquid here at the melting point, and after you pass the melting point, all you are here is you are liquid. And at the boiling point, your liquid is being converted into gas, and as you pass the boiling point, everything is a gas. So the thing really is, what are you trying to do here? You're trying to see where the 25 degrees Celsius is, and obviously we don't need to know the exact value, there's no need to be exact, but 25 degrees Celsius lies somewhere here in between. So I don't know, somewhere there, 25 degrees Celsius. So this diagram are not drawn to scale, it's just representative and make you able to see where 25 degrees Celsius, which is room temperature, where it lies. If you are there, you are still a liquid. All right, so we are essentially looking at A being a liquid. I have a feeling that they are asking for us to refer to a solid. All right, so if you continue for the rest of the compound, so if that is A, and now if I do B, of course you can do the same thing, minus 91, minus 88. So this is the boiling point, this is the melting point. I can tell you that very low boiling point, yeah, minus 88. 25 degrees Celsius is positive. It's way higher than that. It would have already been a gas by the time you reach to positive 25 degrees Celsius. Everything above it is a gas already because it already passed the boiling point. So that must be a gas and E must be out. I really think we are looking for solid. But anyway, let me show you for the rest of it. If I'm looking for C now, so I have 80 degrees Celsius and I have 218 degrees Celsius, and this is the melting point and this is the boiling point, 218. So 80 degrees Celsius is the melting point when you go from solid to liquid. So anything below it, it is still a solid because you haven't melted, right? So your 25 degrees Celsius is below 80 degrees Celsius, and therefore C is a solid. So essentially we're looking for a solid. All right, for completion's sake, let me just go through D. So you can go through this kind of thing with any other examples, provided you know how to apply them properly. So where's our room temperature? Somewhere there, 25 degrees Celsius. Because this is the melting point, so it's already melted but it hasn't boiled yet, so anything in between is a liquid. So D, we are looking at a liquid again. So the ordered arrangement really here is asking for a solid instead of a gas or a liquid. All right, so that's how you can very quickly go through this kind of multiple choice questions. It could also be a structured question. Question 3, it's asking you a pure sample of ethanoic acid. You heat it from 10 degrees Celsius. So you're expected to plot a graph. Okay, so one of the most important skill in chemistry, in fact in any of the sciences, including biology and physics, is to do with graph plotting. And it might be easy to do this on a computer software like Microsoft Excel, which you might or might not know how to do. But then in reality, in a real exam, you are still expected to do it by hand. All right, so let me just get started. So if you are asked to plot a graph to show how temperature changes with time, so this is your y-axis, because how the y-axis changes with the x-axis, right? So as the x-axis changes, this is the value that you are reading. As the time progresses, as the time passes, every minute you will record the temperature. So x-axis is what you change, and the y-axis is what you measure. All right, so the y-axis is what you measure. So I'm not sure if you've done this in lower secondary or not, but what you change, this is a variable. So these are they have a name associated with it. Yeah, these are called independent variable. And what you measure, very importantly, it is called dependent variable. So I have a very good friend who used to teach with me, and what she taught me was there's an easy way to remember this, and it's just to remember that you got to be able to work out what is the y-axis. Why are you so dependent? Why are you so dependent? So it's like an easy way of remembering stuff. So if you can identify the y-axis is what you measure, the y-axis is the dependent variable, which means the other one, x-axis, is your independent variable. Why are you so dependent? All right, let's see how long it would take for you to plot a graph. So this is an empty graph paper. So what you need to do is you need to take a ruler. Okay, you need to take a ruler. I don't have a ruler because I'm working on the screen, so that is all good. So what I can do is, well, I have my straight line there. The first thing you need to do is you need to plot the axis. All right, on the x-axis is time. You gotta have a stroke for the unit, time stroke minute. So any graph you draw, you gotta plot in the axis. This is the x-axis, the quantity, and then the unit. Very important in biology and physics as well. Yeah, and then on the y-axis you have temperature. Do not try to abbreviate stuff that you know you might get it wrong. Don't forget the unit is a very good scientific habit to have. Yeah. So what next? Let's start plotting. So here you have interval of 1, 0 up until 19. So, 0 up until 19. Yeah. So if I start from 0, I will have 2, 4, 6, 8, 10, 12, 14. That doesn't look good at all. Why is that? So essentially I need 20 minutes and I have 2, 4, 6, 8, 10. So it looks like I would need this to be 2, 4, 6, 8, 10, 12, 14. So it's not a very good scale, so you need to practice thinking about how your graph will look like before you actually commit to drawing. Yeah, and the graph should be drawn in pencil, everything should be drawn in pen. Oops, sorry. So that is 20, and what should that be then? That should be 4, 8, 12 and 16, so units of 4. And then in terms of the temperature, so the temperature doesn't exactly start from 0. So what we can do, so we have 10 up until 190. So give or take, that's around 180, right? 180 degrees Celsius. If I start from 0 degree to 200, there's 50, 100. Yep, I think that will do. So that is 50, 100 degrees Celsius. So I can move this on my screen fairly easily, but I don't think you can. So you need to be careful of where you write before you write them. Okay. So that seems alright. 0 degrees Celsius up until 200 degrees Celsius. So 0 degrees Celsius is lower than that, 200 degrees Celsius is higher than that. Okay, so now your job is to put in the value. You gotta learn how to put in the values very, very quickly as well. Yeah, read the x, read the y. 0, 10. All right, so I'll look for 0 and then 10. Because it is 50, so this is 25. So let me zoom this in. So 50, that's 25. So meaning to say this, how do I do this? So if there's 25, then this is tricky. I don't like this at all. Why do I say I don't like it at all? 5, 10, 15, 20. Okay, so it's like every two small square is 5, 10, 15, 20, 25. All right, this is a bad graph. If I have a graph paper, I will choose a better scale. It's just that they have they're given us this graph, so there's nothing we can do. All right, so 0 and 10, 0 and 10. Okay, so that's the first point. 1 and 17. So 1 and 17 all the way to 5 and 17 is a straight line. Yeah, 1 and 17. Okay, 17, right? How do you find 17? So that one is 10, that one is 15, that one is 20. So the way to find 17 is it's somewhere in between 15 and 20. So 4 and then somewhere in between, just give and take somewhere in between. Okay, I would say somewhere in between there. And then obviously I know 2 is there, 3 is there, 1 is there. So it is pretty much like a straight line like this, up until there's 5. 1, 2, 3, 4, 5. And then number 6 is 20. Number 6 is 20. 20 would be go up a little bit. 7 is 40, 8 is 60. 7 is 40, 8 is 60. There is, there is 55. So 8 is 60, right? 8 is, there is 60 there. And then what else can I do? 40 should be 7, right? So 7, 40. There it is. Okay. So plotting graph is not as easy as you think it is. Yeah. If you get a good graph, big graph is easier to draw than a small graph like this. All right. 10 and 100. 10 and 100. 10 and 100 is the easy one to draw. 11 and 118. Things like 118, I would think that is really close to 120. So look for 120. As you know, 2 small square is 5. So 120 will be 4 small square. 120 is roughly there. So what do I need? 12 is 118. 12 is 118. 12 is 118, so roughly there. Okay, and then 11 is also 118. 11 is also 118. No, I need to be the same thing, right? Okay, 13 is also okay, so basically it remained 118 up until 16. All right, so up until 16, so 16 is there. So it's not that bad. As you can see, this is a heating curve, constant, goes up and then constant again. And then 17 is 135, 18 is 160. Okay, I do 18 first. 18 is 160, that's the easy one. 18 and 160. And then 17 and 135, 17 and 135. 17 and 135, 130, 135 is there. All right, 19 and 185, 19 and 185. So this is 175 because it's in between 150 and 200. So 185, so 185 would be this. So this thing there is 175, 180, 185 would be there. All right, hang on, I lost it again. 175, 180, 185. Okay, cool. So well, there we go. Okay, let me change my pointer to be a bit smaller, and let's get started with drawing the graph. Oops, I don't want that. You see how it's not allowing me to. So there's a slight straight line there, and then it's like a curve, and then it's like a straight line there, and then it's like a curve like that. All right, so very clearly this is a heating curve because the temperature is continuously going up. Okay, and when the temperature is going up means that we are supplying heat, and that's because we are heating something. That's why we are supplying the heat to heat something. All right, okay, I guess in a real exam, in a real O-level exam, you won't really be expected to plot this graph. You'll be expected to analyze it, but you'll be expected to know how to plot a graph, especially in a practical paper, not just for chemistry but also for physics and biology as well. So it's a good practice. Yeah, okay, so add these two labels in the correct places on your graph: melting and boiling. Melting is solid to liquid, boiling is liquid to gas. So we know that that is the melting point because that is the first temperature where it remains constant, and then this will be the boiling point. Okay, so which change takes place within the first and the 5th minute? So there is the first bit, there is the melting point because you are having this change of state, which is called melting. Identify a time meaning this is the x-axis, because if you read the graph, the y-axis is temperature. All right, evaporating but not boiling. All right, at this point it is boiling because the liquid is going to gas. At this point the solid is going to liquid. Between here and here it is still a liquid, and evaporation can take place at any temperature below the boiling point. The liquid that have enough energy can become a gas. That's called evaporation when the temperature is below the boiling point, meaning before you reach the boiling point you can already evaporate off. So give a time, so I would say somewhere in between, so maybe like 9, 8 is also fine, 10 is also fine. All right, but time has a unit depending on the question or the data given, so there's in minutes. So I could use like 9 minutes or 10 minutes or anything in between. Anything in between, I would say 7 to 10 would have been all right. Anything between 7 to 10. Maybe I go for 9. Anything 7 to 10 minutes. Yeah, 10 minutes is still alright because they're still below the boiling point. Alright, so 7 to 10. Identify a temperature. So this is your y-axis now. It's called the dependent variable. Why are you so dependent? So you want the particles move around slowly in a random way. So the fact that they already told you in a random way means that it can move with a bit more freedom compared to this. You see, this is a random way and it can move, but it is slowly. If this is a gas, it will move around very fast. All right, it will also be random. This is a solid. A solid only vibrate about fixed position because a solid does not move randomly. Just like solid do not flow, but liquids like water, they flow, right? So they can flow easily. You can pour liquid, but you can't pour solid. So that must be liquid and not gas, because this is slowly, and liquid move around slowly, gas move around very fast. Fill the available volume. That has to be a gas because gases do not have a fixed volume. Ethanoic acid is cooled from 150 degrees Celsius to 0 degrees Celsius. So this is cooling. Sketch a curve to show how the temperature will change over time. So what do we know about the melting point and the boiling point? The melting point is very clearly 17 degrees Celsius because this will remain constant, and the boiling point is 118 degrees Celsius. Alright, so the melting point is 17, the boiling point is 118. The melting point is 17 degrees Celsius, the boiling point is 118 degrees Celsius. So if I have similar kind of graph, so they're given us a very small diagram. Yeah, I don't know why. All right, temperature, degrees Celsius, and then time, minute. So this is a cooling curve. What are the important criteria? So the temperature will go down, and then it will go down further, and then it will go down like this, and it will go down like this. All right, so we know that this is the gas to liquid, so this is the liquefying, so it's basically the condensation, and this bit is the solidifying. Basically it's the stage where you form the solid, meaning to say it has to be freezing. All right, and one of the important thing that you have to label on your diagram include this value there, which is the condensation point, which is equal to the boiling point. So that is 118 degrees Celsius. Actually, I don't need to put in the units because I already have the unit on my graph label. All right, so so here this is the solidifying point, meaning to say that is the freezing point, that is 17 degrees Celsius, which is equal to the melting point itself. They want you to sketch a curve. I've done that. They want you to add this label. I've done that. They didn't ask you to label the graph, but anytime you draw a graph, you have to label it. Okay? In this last question, liquid bromine forms a red-brown vapor when you place it in the bottom of a gas jar. So bromine is heavier than air. So they tell you that bromine is heavier than air. In fact, in a later topic, you will be able to get this information by knowing what is bromine and what are the components of air. Yeah? Draw the particles in the empty gas jar to show their distribution after 24 hours. So we are talking about diffusion here. So diffusion is to do with random motion. So the particles will move from the region of high concentration. So here the bromine is highly concentrated there. It will move in random direction, and therefore you will get this dispersion of the particles, where the air particle is still dispersed like this, but you have a bit more of that dark bromine particles. So if I use black color, maybe I use I'll use a black color. Show the field bromine like this. So it doesn't need to be regularly arranged like this, because well, you know about gas particle and their motion, right? So essentially what it is now everything is kind of like spread out, because you allow the diffusion to occur from the region of low high concentration to a region of low concentration. So the idea really here is random. I really want to use a bit of color to show the contrast. Yeah, so it is definitely as a result of random movement of particles. Okay, so do a random motion. Cross out, cross out. So this is the instruction. Incorrect one, cross out. So the bromine particles in the gas jar moved from where their concentration was high to low. So I cross out the incorrect one, high to low. Follow instruction, read, circle, underline, whatever, read the instructions. Yeah, from high concentration to low concentration, it gets spread out. Over time, the concentration of the bromine particles it doesn't become zero, it becomes the same because it's become uniformly distributed. Remember, gases like to fill up the volume of the container. This is a closed container, so they just go on everywhere in random motion and fill up the space in the container. This is an example you have seen in lower secondary, or I might have demonstrated to you. Probably I will at some point. Diffusion takes place in liquids too. Suggest one way to demonstrate this in the lab. Because you want to demonstrate it, you need to see this. In order to see this, it doesn't make sense if I use something which is colorless because you can't see it. All right. So typically, this is what we will do. We dissolve. We don't try to dissolve. We just place a small sample of colored, in fact very intensely colored, very dark color. Yeah, intensely or dark colored is actually purple colored potassium. You learn it as potassium permanganate in your lower secondary, but you will learn a different name very soon in O-level, in a beaker filled with water. Over time, meaning to say after some time, maybe even after a few minutes, the purple color starts to appear in the solution, starts to appear in random parts of the water or the solution. Actually, the solution is better, okay, because the water doesn't change. It's just that as the intensely colored thing starts to dissolve in the water, without you stirring it, there is actually diffusion taking place. Alright, so that's it in this tutorial. So I hope that was useful, and ask me anything if you have any questions.